right, everyone. Welcome to the next talk. So here it says, Backstage is not your platform. Well, I don't actually have anything against Backstage, right? So don't get me wrong. I'm actually a big fan of Backstage. It's definitely a nice product. But you really need to treat Backstage as what it is, right? It's a front end for a platform. So I'm Nils. I'm working at Humanitec. And as Humanitec, we help a lot of teams to build internal developer platforms. And we are also strong supporters of the platform engineering community. So today I'm talking about Backstage, the open source project developed by Spotify. Has anyone of you heard about this before, or maybe used it even? That's awesome, you know it. So if anyone doesn't know it, it's not to be confused with the Backstreet Boys, yeah? Just a little bit of pun on the side here. So Backstage is an open source framework for building portals, right? So you can scaffold with it, so you can build your new service from a template, basically, get it alive, and you're able to build dashboards with it. So it's a display layer for your platform. It's also a CNCF project with a lot of traction, and it has a nice open plugin architecture, right? So you can build your own plugins, and there's even a Humanitec plugin available to interact with the Humanitec Platform Orchestrator API, right? On top of that, there's several hosted and managed options available for it as well. For example, the Red Hat Developer Hub, and these guys are actually driving a lot of the open source development right now. So definitely interesting to check out if you haven't already. So let's talk a bit about platform engineering. So platform engineering has been on the Gartner hype cycle for quite a while now, and they also predict the truth of disillusionment. So everyone is hyped about platform engineering right now, but will probably hit this disillusionment somewhere in 2025. I believe one of the reasons for that is that people are abusing Backstage by using it for something it's not meant to be used for. From what we see in the platform engineering community and also as Humanitec is that roughly 60% of platforms are built with Backstage, which is a lot. Based on our internal assessment, we saw about 500 to 600 platform engineering initiatives at larger scale last year, and we think that this has tripled this year actually. So it's a lot, and there is a lot of pressure actually on the GitHub project of Backstage, right? So in terms of building platforms, the most impressive failure story I have seen so far is Netflix. So firstly, they displayed it quite openly. And secondly, they are kind of the poster child for platform engineering, and they get referred to a lot. So they started with their platform engineering in 2022 with plenty of enthusiasm, and they also gave a talk at PlatformCon. And then in 2023, they had another talk, and in this talk, they actually said, the view and access experience provides value, but on its own, it's not yet compelling enough to pull users in, away from existing habits and routines. And I do believe this is a polite way of saying that they built this, but nobody is really using it. When I'm summarizing the issues they describe in the talk, it's basically adoption is not high enough, it's hard to maintain, and the development self-service layer becomes too stuffed. So what I would like to explore with you, that we cannot index what a single part of a platform will deliver. A platform is a sum of all tech and tools platform engineers put together to provide a golden path, to build a unified developer experience, to lower the cognitive load, and also doing all of this with the different user personas in mind. Let's play a little game of infrastructure Tetris. So in Backstage, it's quite easy to build like buttons for your developers, which they can use to create certain resources, like clusters, S3 buckets, databases, and so on. So they keep pushing those buttons, and they are happy that they get resources created, right? One more and another more, and this workload needs another one. But on the flip side, you have infrastructure teams which need to maintain and clean up those resources, and those resources might not fit the standards you would expect for security and reliability. So it's great to have a front end which does things for you and shows you dashboards, but that's only day one operations, right? So when you design these sort of things, you also have to have in mind that it needs to be sustainable. Let's have a look at this pain to impact pyramid. So what are the actual pain points we are trying to solve? There are the developer needs, but there are also more people in this picture, like the infrastructure, ops, and security teams, right? So with their own challenges. And we should not optimize the experience of one group at the expense of another. This is a multiplayer game, right? There are essentially two key value drivers I see here, which is standardization and automation. And you need a spokesperson in standardization. And you need a spokesperson for each of them. So one taking care of the infrastructure part and the other one taking care of the developer experience part. And all together, we need to serve the common goal of the organization, which usually fits into like faster time to market, cost down, innovation up. The key here is there are multiple stakeholders which need to work together. So how do we actually handle this? We want to achieve a high degree of automation and standardization, which leads to a high return of investment. Let's look at a small example of a low degree automation with the example of a developer needing a Redis cache for the workload. So here we have a CI pipeline to apply the code and configuration changes to the workload, and maybe a Terraform to create and manage a Redis in a cloud. But that's only 10% of what needs to be done. There's still a lot of manual actions which need to be done by the developer. Like they need to check, for example, like policies for creating this Redis instance. They might have a manual sign-off, and you also need to provide those application secrets into the secrets management and then refer them in your code again, right? And you need to do all of this for each of the different environments for your application. You want to be in a world where the user expresses their need on the one hand, and everything is done automatically. This can be difficult to achieve from just a display layer calling an API. And second, there's standardization. When you click the button to create your database with the standard configuration, it's all fine. But then you have developers, DevOps engineers, security teams doing updates over time. And this is when you get configuration drift, right? Suddenly, all the different instances you have created for your workloads, they suddenly look different. So what you want to achieve is standardization where it's possible to synchronize changes for a specific type of database across all instances. So if we say just a display layer on top of what we have is enough, please think again, there's a lot to consider. What's important here is that you think about your platform as a whole, including its architecture, right? So otherwise, yeah, it might look interesting. So this is a platform architecture diagram, and we are publishing those on platformengineering.org/platform-tooling, and you can find this in all kinds of different flavors essentially, and we purposely publish those so you can reuse them basically to build your own kinds of architectures you want to have. So in this architecture is separated into different planes to describe the different interaction methods. This has been designed by McKinsey and was introduced at PlatformCon 2022. And here we see that platform architecture is a lot like a software architecture. And when you have a front end, which you need, you can only stuff that much functionality into it until it becomes maintainable. So if you have a front end, you also need a back end. And I'll show you two examples in a second, about possible backends here. But let's dive first a bit into the developer plane first. When we remember the Netflix platform failure, they said it was not yet compelling enough to pull users in away from existing habits and routines. And I would argue here that this is not what you want to do. You should rather choose a middle ground and offer them interaction ways they are already used to, like through specification files and code and a supporting IDE, or via CLI and API. So when it comes to backends, there is this historic way of doing this by using pipelines. I mean, everyone is still using pipelines. But this would include basically a CI system and an image registry and a CD system like Argo CD, or maybe just Helm charts and some automation to deal with infrastructure like Terraform or Crossplane. And this might be a really good approach specifically for smaller setups like 20 to 50 developers. You have short ways of communication, you don't have many resources, and pipelines, in my opinion, work pretty well here. By now, everyone in software development organization knows how pipelines work, but it's hard to scale with simple pipelines. They are a start-stop system which operates linear, and it's hard to build advanced logic with them. The amount of pipeline code you need grows exponentially with the amount of resources you want to use and manage. What we have seen is that this approach becomes economically unmaintainable with more than 50 developers. When you design platform architectures well, you want to detach the growth of the platform team from the growth of the development team, right? So that your platform team can stay the same size while your development team is actually scaling. And this is why I'm a fan of graph-based backends, so-called platform orchestrators, right? And by now, there's not only Humanitec providing these types of systems, but there's other products on the market as well. So let me show you how this works in a little bit more detail. So here we see a product called Score. It's open source. We started development at Humanitec quite a while back, and we donated it now to the CNCF, so it became a CNCF sandbox project in June this year, which actually makes us quite proud that we managed to get this going. The core to a platform orchestrator is to combine an abstract description of the world with generalized rules, right? So Score provides an abstract description of a workload and its dependent resources. Score is environment agnostic. It is essentially one file which sits next to your code. For local development, it can be translated into Docker Compose file, and for any cloud environment, there are other Score adoptions like Score K8s, for example, for converting it into a Kubernetes YAML file. And since it's open source, there's already development happening for other systems as well. So let's have a look in more detail. So we have basically a product service here. It's configured with an image with a couple of variables. The important part is down there. There's resource dependencies basically defined, right? So you have your Postgres database, you have your S3 bucket, you have a DNS and a root described there. And if you would just send this to any system, the system cannot do anything without it because it doesn't know how to provision your resources and how to configure them for your specific environment, right? So there's one part missing. And, and this is what we do with the set of general rules, right? They are essential to train your backend to understand those conventions. And for this, we have resource definitions. So in this example, we have a resource definition for a Redis instance. There's a link to a GitHub repository, and in this GitHub repository sits the Terraform code, which is required to get this Redis instance up and running. And we also see the context where this should be deployed, so to staging, for example. So let's go through this flow, how this works with a graph-based backend, right? So on the one hand, we have infrastructure and operation teams who are setting a set of rules, right? So this needs to exist first, like the different contexts where you have your resources deployed in. And then you have your developers, which come with a score definition, and in the score definition is not only the code referred to as a container image, but also those resource dependencies. So the CI is triggered, the platform orchestrator is called, it receives the context staging, it can look up based on the resource dependencies what rules will be applied and what resources need to be created and what the Platform Orchestrator can do for you is basically building a resource graph. And based on this resource graph, all those resources basically get created. The important thing here about the resource graph is also there could be like sub-dependencies, right? So it needs to be starting at the lower end and then creating all the dependencies up first. And this is why we always have a graph for this in place. So let's talk about two more examples here. One, the developer wants to add a Redis cache to the application, so they update the code basically, and they add the dependency. And then next, the CI is triggered, and am I going too fast? No. The CI is triggered, and with the context staging again, it looks up the rule for this, and then based on that, Redis can be added as an application dependency, and infrastructure as code can be called to create this Redis instance. And then the second example here is the infrastructure team also needs to do an update because they need to publish a new Redis version, because on the old Redis version, there's a security problem. So Redis needs to be updated by infrastructure and operations team. So they basically update this resource definition, this rule, and then with the next deployment, which can also be forced by the team itself, the Redis version will get updated, basically. All right, and when you have this sort of backend in place, then it's time to put a frontend in front of it. And please remember, a frontend is a frontend, is a frontend, is a frontend. Thank you so much. Come visit us at the Humanitec booth. I would be very happy to chat more about platform engineering, or if you're interested in SCORE, I also have a little demo prepared, which is deploying directly to a Civo Kubernetes cluster. So, thank you very much.
Any questions?
Hello. I know at the start you mentioned how you had like a bucket and all the developers, they wanted a new resource, and they all got dumped in there. How does this graph then eliminate what needs to be deleted and looked after by the ops team? Yeah, so the issue is not that the developer needs get fulfilled here. The issue is that the platform team is not involved in this, right? So the problem here is that these kind of resources, they might not follow any conventions. They follow whatever is basically defined inside Backstage. And if you just throw like Backstage in front of your resource provisioning, you don't have this generalized set of rules, which is also following certain contexts, right? So and then you're getting into trouble with your platform engineering team, which needs to suddenly maintain like lots of different resources, and they don't know what they're actually for. And who is using them, right? And this SCORE YAML is per repo, or you sort of have it in a catalog that everyone sort of goes to get for standardizing the services, or how does that look? So you're talking about the SCORE file, right? So this is a definition, a file which lives inside the code next to your workload, right? So it's basically per service, per microservice, you could imagine. But to get this standardization, you would sort of offer them to teams to say, look, this is a Go, or this is a TypeScript, or whatever you want, and you say, this is what we suggest, or how do you get that standardization across the org? Yeah, so we are trying to convince like the development teams of our potential customers by telling them this is a nice option for you to have like one specification file, which you can use for local development, so you can convert it into a SCORE Compose or maybe other systems to just run things locally and see. And you don't need to change anything on your specification to just pass it on to your platform engineering team, who might then just run like SCORE K8s, for example, to convert it into a Kubernetes manifest file, or use a Humanitec, for example. Gotcha, thanks.
Hello.
Hey.
So let's say, for the sake of argument, that the Postgres is deployed with a Helm chart to a Kubernetes cluster. Yeah. When updating Postgres, you need to do some manual steps, especially major versions. How much does this lock you into using the score, like score specifically, how much does it lock you in to do it the score way versus on these rare major version updates, how much can you just jump in and do your own stuff?
Yeah. So, like let's say your developers are using Score, they define their resource dependencies, and you're using the Humanitec orchestrator to then trigger deployments and stuff like that. So what usually happens is that your platform team can basically put in a resource definition for Postgres inside Humanitec using a Terraform script. So they would just reference a Terraform script, and they could maintain this and also write this Terraform completely themselves, like they are in full control. And they would basically also in this Terraform what would need to describe like the upgrade process from the one version to the next version, so that it can be executed. But the important part here is that the platform team is fully in control, and the developer, they just trigger the next deployment, and if it's pulling in a new version of Postgres, for example, then it will be deployed with that.
Thanks. Thank you for the presentation to start with. Another question about Score here. So I understand this file lives in the repository of the service, so it's under the ownership of the service owners, let's say. I guess when they make changes here, they have the review process, they approve it, and then they merge it. Are these changes then propagated to all environments, or how would you control that? And how do you make sure that developers that maybe are not so proficient with the infrastructure, that they don't delete something, let's say, that shouldn't be deleted?
So that's a good question, and I have to say it highly depends on your setup. So the general idea is, yes, Score lives with the code, and the idea is that you have a CI pipeline which is triggered based on changes to Score. What we, like on the one hand, there's possibilities to do like deployment to different environments via your pipeline, but what we also offer, since we already have like the management of environments inside Humanitec, is we also have a CD system, a pipeline system specifically for CD inside Humanitec, and we can also define the pipeline YAML from Humanitec basically inside the code, where it's then defined like on what steps of the review process, like after a PR is merged to your main branch and stuff like that, when should get things deployed basically, right?
Okay, so in the end you use the pipeline approach still, it's just that the user input is a bit different.
Yes.
Okay.
Yes, I have to admit we are using pipelines.
Thank you. I think that's it.
Cool. Thank you so much.
Thank you.